Hello, my name's Tony Cotton, founder of Energy Conscious, and I'm here today to share with you our experience in implementing a smart DC lighting system that runs over Cat5 cable called LumenCache, or LC for short. This is the second in a series of videos on this system, and today we're going to talk about system components. And that includes wiring, lights, switches, power, including backup in case there's a grid outage, and automation. So let's get started. So here is our system mounted in the basement of our rehab unit up on Valley Forge, PA. Here we have our structured wiring cabinet, which is going to contain the bulk of the LumenCache system, all the controls, etc., power supplies, that kind of thing. Then over here we went ahead and put up a demo board so that we would be able to have all the types of lights and different mechanisms, so we could have it all in this kind of a instructional video. So first what we're going to have is, here we have the AC power coming down through an AC disconnect into the structured wiring cabinet into this AC to DC converter. Then which is backed up by a battery in case of grid outage. If the battery needs any charge, that will just go ahead and top it up. Otherwise, it'll float over through these 15 amp DC breakers up and servicing what they call the power distribution module, or PDM. From here, the different electronic components that are plugged in one of them will read the light switch signal inputs, and then based on that determine how much current to send out to through the other component, which is the actual LED driver. So the signals coming in and the power going out are all running over these Cat5 cables that service the LC lighting circuits throughout the house. One of the most significant differences in installing a LumenCache lighting system will be the cabling or the wiring. In the case of LumenCache, it's all going to be low voltage Cat5 cable, similar to what you would use to connect your computer to your router. Both the power and the intelligence are going to be transmitted over this cable. So the way you connect your Cat5 cable to the various LumenCache devices is through a thing called a structured interface block, or SIB. Here we have a single SIB connected to a light switch. Simply plug the Cat5 cable into the SIB and you're good to go. If we have a daisy chain topology, then you're going to need what I call a pass-through SIB, similar to this. It's got one port that comes in from the PDM and one port that goes back out to the next device in the chain. The only gotcha you have to be careful of is a jumper that is called the last light jumper. If it's the last light in the chain, it needs to be set. Otherwise, leave it off. So the next component we're going to talk about is the lighting, or the lights themselves. I want to make a distinction between the AC version of an LED light that you would buy in Home Depot versus the LumenCache model. In the Home Depot version, or any commercially available version, you're going to have all of the electronics that convert the AC to DC and the LED driver built into the base of the bulb, whether it's a single bulb like this or whether it's a ceiling light fixture. The difference is that LumenCache takes this electronics, this conversion electronics from AC to DC and the driver, and they have abstracted it back to the PDM in these devices back here, which we'll talk about in a second. So when we first started, the only lights we had available to us were the proprietary LumenCache small form factor lights that were specifically designed for DC. After a while, we stumbled onto the Amazon lights that were standard off the shelf, $20 torch star, and we actually had a driver that was wired to the light that we could cut off. So once we cut that driver off, we just wired it up, and we could use the LumenCache drivers to support that light. With the ceiling lights covered, we now could, that was the bulk, our core requirement for our emergency lighting system. we decided to step into multi-bulb fixtures similar to this, or LED light strips. Now, once you move from these ceiling lights to multi-bulb fixtures, you have to move from a constant current driver to a constant voltage driver. The issue becomes a constant voltage driver can support a little more than 1 amp. 1 amp at 12 volts is about 12 watts, so maybe you have 12 to 15 watts. So then you have to decide whatever your multi-bulb fixture, in this case, this is 7-watt DC bulb, 14, 21, 28. 28's well over our limit, so we cannot support it with just the driver itself. We have to add an optional piece of equipment, which is this LumenCache amplifier, which can take us to 100 watts, more than enough for our needs. The big issue in moving to the multi-bulb fixtures is not the fixture itself. This is a standard $15 light fixture from Home Depot. It's the bulbs. They consume DC directly. They're 12-volt DC bulbs. They're currently limited, high-priced. There are more models popping up online, and so the price is coming down and the availability is going up. The next component is switches. LumenCache offers the standard Decora momentary switch, where they will have a SIB and a 47K ohm resistor already attached. The 47K ohm resistor is to facilitate the dimming function, but it's no big deal for you to go and buy them off the shelf and add your own SIB and 47K ohm resistor yourself. The function of the dimming, so the momentary switch, 1 tap will be the dim or restore level, 2 taps is full on, off, or if you wanted to dim, you would hold the bottom down until you hit the desired dim level and release. So that momentary feature is necessary to do that dimming. Our final component is LC automation. We're only going to gloss over this because we're going to dedicate a separate video to that topic. But once the LumenCache system is up, all the lighting circuits are available for control via this COM bus port right here. We have that connected to our choice of a hardware platform. It's open source. It's a Raspberry Pi Model 3. It's a quad-core processor, costs $35. It's running a full Linux stack, and not only are we using it to support the home automation controller, but I'm also using it for my remote development environment. We initially put on, from a software perspective, HomeSeer, a very popular low-cost home automation software package. We ran into a problem with trying to support the Linux serial port, which drove us to look into another IoT platform called Node-RED. Here we have a simple, plain vanilla user interface built on Node-RED that is now connecting to our home automation controller here on the Pi. If you're interested in the LC automation topic, check back later. We're going to have a full deep dive into how to drive the Raspberry Pi Node-RED from Node-RED. Let's close out this video with a little demonstration of LumenCache resilience and energy efficiency. Remember, from an earlier video, one of our primary objectives in evaluating this technology was to be able to use DC power from potentially a battery-based PV system directly without having to convert it first. If we were to have such a battery-based PV system, all this power electronics in the bottom of our cabinet here would be gone. No AC-DC converter, no battery, no charger. All we'd need to do would be to bring the DC power straight from the PV system straight up into our PDM. So let's take a look at the resiliency. I'll go ahead and turn on one of the demo board lights. We'll simulate a grid outage by turning off the AC power. no flicker. The battery is carrying the system right now, and that would apply through all the circuits in the house. Let's do a little test. Luckily, we've installed a DC power meter in our demonstration setup for just this purpose. Let's take a look. Just under 15 watts. Now let's turn on the family room lights. Full on. The kitchen lights. Full on. The hallway lights. Full on. Moving to the second floor. The first bedroom. Full on. The second bedroom. Full on. Now what is your guess as to the total power consumption? A quick check back at our meter shows just under 110 watts. That's 110 minus 15, less than 100 watts. So the majority of the house lighting is on and is consuming less than this 100 watt incandescent light bulb. Now that's progress. We are quickly moving towards smart homes powered by clean energy. LumenCache met our objective of a home lighting system that's smart, extremely efficient, and resilient in the face of grid outages. Currently, common off-the-shelf versions of lights, switches, fixtures, and bulbs are available. As homes follow businesses incorporating direct DC consumption technologies, available components will become cheaper and more widely available. We believe your home can be energy conscious.